with complex roots. Before, when we were finding the discriminant, when would we stop and say there's no real solutions? When we have a what?
When there's a negative.
Right, because if we look at our quadratic, I'll bring this back in. If we look at our quadratic, when it's negative discriminant, what do we end up with? What do we end up with down here?
No real solution.
No real solution, because then you have a negative under the root. But we did learn, and we reviewed it for the midterm, we learned a way to deal with the negative under the root. What was the special kind of number we deal with?
Imaginary numbers.
Imaginary numbers, which an imaginary number is part of what's going to be called our complex roots. Complex roots are going to have some imaginary part to it. Okay. What's nice about this is, as you'll see when we do the practice problem, you end up with the plus or minus really, really quickly. Really, really quickly. But just to review, remember when you have a negative 1 under the root, that's equal to I. That's equal to I, our imaginary number. Those are exactly equal. Those are the definition of an imaginary number. And remember we had I to the second, I to the third, I to the fourth, and they kind of rotate. We won't actually have to go that deep into that aspect, because our answers are just going to be a complex root. It'll just have like a, negative 5 plus 2i over 2, negative 5 minus 2i over 2. It's going to be the plus or minus split. That's all we can solve, because you can't break that up anymore. So, looking at this, negative 9. Everybody okay if I say that it's this? Negative 1 times 9? Under the root, you could break it up however you like. It's multiplication, the same thing. Negative 1 times 9 is negative 9 under the root. Okay. So, what is the square root of negative 1? What's the identity that we know about the square root of negative 1? I. So, this is equal to I. What's the square root of 9? 3. Right? Right? You break it up, you take out what you can. In this case, we had nothing left over, because both of these we can take the roots of. But if you had, as you'll see with some of these numbers, you're going to have something left over in the root. It's no big deal. No big deal. All right. Negative 12, what does that break up into? I'm always going to put the negative 1 out front. And then 12 breaks up into what? 6 and 2. Those aren't perfect squares, though. Any others?
4 and 3.
4 and 3. I like 4. So let's go 4 times 3. All right, which of those can we pull out of the root? Negative 1. 3 isn't a perfect square. We won't be able to pull it out. Which one of these is a perfect square? 4. All right. So we take that out, we take that out. Square root of negative 1 is I. Square root of 4? 2. What's left over on the inside that we couldn't get out?
2i.
3.
Oh yeah, 3.
2i's on the outside because we were able to take those out of the root. All right, I want you to do the fourth example here, the third example. Root negative 20. Break it up. Make sure you take that negative out. Then check with your neighbor real quick. Check with your neighbor.
Oh, I got it.
All right. Where you need to go to the bathroom or something?
No, I just want.
All right. Yeah.
Why is it 2i?
For this one. So first you split it up into some multiples, hopefully one that has a perfect square. Now, I know that the square root of 4, if I'm going to take it out of the square root symbol, I need to take the square root of it. So when I square root 4, I get 2. The square root of negative 1, the definition of it is 1, or excuse me, I. So then on the outside it's the 2i, because I was able to take both of those out, 2i. The root 3 we couldn't deal with. The root 3, we have to leave it in. See what I mean?
Yeah.
Right, TK? Okay. Yes?
Did I get it right?
Okay, let's bring it back together so you can see it together.
2i square root of 5.
Yeah. Confidence. Confidence. All right, here we go. Square root of negative 20. Where should I start? TK, where should I start? Good. And the negative we can kind of take out just like we had, right? Negative 1 times 2, 4. I see your head. I got you. 4 and 5. You're already taking things out. All right. Yeah. We can square root the 4 we get. 2. Square root of -1. All right. What's left over? All right. Raise your hand if you got that. Raise your hand if you got that. All right. That's almost everyone. Good. All right. Feel okay about this? Feeling okay? What's it? Low key easy. I like it. Low key. Like Thor's nemesis, Loki.
That was a good one.
It couldn't make it into a joke, so I made it like trivia. Try to make it.
It said low-key evil. And then
I'm not sure. You did. That's what it did.
he's always like in the middle. Like he's gonna be the one.
We did this already. All right, we already did this one, so I'm just gonna fill it in. This is the discriminant. Go ahead and do that on your notes. So remember the discriminant. When the discriminant is negative, we're going to end up with those complex roots. All right. Here is. Okay. Oh. This thing. Yeah, there. Okay, so here is our quadratic. First, A, B, and C. A.
1.
B.
-1.
C.
2.
I like those. Those are pretty easy numbers to deal with. Okay. Let's go ahead and do the discriminant first. Even though I know what I'm going to get, it just makes it easier to deal with. -1 squared minus 4 times 1 times 2. All right. -1 times -1. What? -4 times 2. -8. We got -7 in there. All right, which tells me before I'd say no real solutions, so I know I'm going to have some complex roots. Some complex roots have imaginary numbers. No big deal. Feeling pretty good about this. And then actually finding the roots, no problem. All right, x is equal to -b plus or minus √7 all over 2.
-7.
Thank you. When it's raining, my
No, we're even now.
we're even. We're even. All right, so we get 1 plus or minus √7 over 2.
-7.
Just catch it to see if you're listening. What can we do with this √7? It's actually -7.
Oh, yeah.
See if you're listening, just see.
Oh, I wasn't listening.
I know. We can split this up into, think of it as √-1 times 7, and then what are we going to do with that -1 under the root? We can do what?
Change the
Get rid of it.
And it turns into n 1 plus or minus I √7 over 2. Okay. So here's the deal. √7, it's totally fine to leave it there as √7, because if you multiplied it and made it into a fraction or a decimal anyway, it would just be 1 plus or minus I. Let's see, what is that? I, or you could say 2.41i. You know, it doesn't matter if you leave it as a root at this point, because we're not actually going to get a tangible finite number with that. We're going to end up with I involved anyway. So I would go ahead and say that my two answers for this, x is equal to 1 plus I √7 over 2. X is equal to 1 minus I √7 over 2. See, they start to throw in those complex roots, and they think it's going to really throw us off. But is that going to throw us off?
Heck no.
Like, no, I don't think so at all. Yeah. No? Oh, yeah. Okay. No. Got my two roots. We aren't doing the inequality, so there's nothing to graph as far as the number line goes. But we have the plus and the minus option. Okay. What do you guys think? Surprised?
Is that it?
Those are our two answers. We're done.
Awesome. So you just have
See?
to put a plus or a minus
Really, you're just breaking the
next
two
to
roots.
that imaginary number.
Absolutely. Now, this might be more complex, but just say that this was root negative 128. Let's just pretend. Let's pretend this is plus or minus negative 128 over 2. So what does 128 break into? First, I need to get that negative and move it out. So what is 128? Good. So before you do that, just break 128 up.
Yep.
And you got 2 times 64, right? Okay. So we get 1 plus or minus. We could take the negative out. We can take the 64 out. So we get 1 plus or minus 8I root 2 over 2. See? It's not, that's as hard as it's going to get. Basically, everything we did Monday when we were doing the quadratic, this is just, instead of saying no real solution, we just go the step further, and we deal with bringing in the complex roots, bringing in our I values. I want you to write here for the last bit here, and this isn't something I have to label every time, but these two things, these two complex roots, are called complex conjugates. Okay, complex conjugates. Basically, if you were to multiply these together, you would get rid of your imaginary components. The answers are always going to end up being this way, because you have the plus version, you have the minus version. When you'd actually multiply them together, all your i's would disappear. Okay, that's just another kind of definition. Woo! Well, we have 10 minutes, so here's the thing. Let's see. Let me just pause for a moment so we can have a democratic. All right, if you're in this battle competition, you got to come on up. You got to get your feet ready. Stretch those feet out. Uh-oh. We lost momentum.
Yeah.
Is that like a Russian dancing?
The Russian dance.
Alright, that's good, that's good. That's good. Yeah, that's like 300 views by tonight. Alright, 123rd gets Oreo package. Delicious, vegan, chocolate. Wow.